the question is, we recently had the strongest solar energetic particle event of solar cycle 25. What happens during an SEP, including what the GOES and 16 and 18 proton flux are measuring? Well, so first of all, what is a solar energetic particle event? It's the emission of high energy protons by the sun. And it usually happens like we catch them, these energetic protons on Earth, when the sun, like there's some sort of flare or CME that happens, like somewhere here in the right portion of the sun as viewed from Earth, because that's the area, roughly the area where we connect to the sun by the interplanetary magnetic field lines, as we've seen in previous videos. Okay, so then these energetic protons created by the flare or whatever other event on the sun might follow these magnetic field lines and reach Earth very quickly because they have a lot of energy. So it takes maybe 10 minutes, half an hour, up to an hour. So the regular, slow plasma, it may take it like 2 or 3 days to reach Earth, and these faster particles reach Earth in a matter of like tens of minutes or hours at best. Okay, so what do they do? Well, you may remember we previously discussed like what happens to regular protons from the solar wind. So they get deviated by the magnetosphere, right? We've discussed the exact, well, more or less exact mechanisms how that happens. But these protons are much more energetic. They're moving with almost this like the significant fraction of the speed of light. Could be like a half of the speed of light or something. So they aren't as easily deviated by the magnetic field. So they can move closer to Earth. Like eventually they would be picked up by like these polar magnetic field lines, and most of them do get into the polar areas because of this. Some of them do get into the lower latitudes for sure, but most of them still get into the polar areas. So what do they do? Well, first of all, like for satellites in orbit, they can cause like charge buildup. They ionize the stuff that the satellite is made of. They ionize the biological tissue, so it's not very cool, for the astronauts to get into this radiation storm. What can they also do? They will ionize the atmosphere, of course, which causes, for example, an increased absorption of high frequency radio waves. So like it can cause potential issues with like GPS signal reception and things like that. So the basically the ionosphere becomes less transparent and even less reflective for radio waves. Like it starts absorbing them. So it's not very cool for technological things in this respect. That will be it. I mean, I've seen some papers that have discussed like hypothetical impacts of solar energetic protons on some other stuff. Like some paper a while ago was talking about how like they found a correlation between forest fires and solar energetic particle events. So maybe these high energy protons actually may trigger some sort of, I don't know, a spark, roughly speaking, or something to that effect. I mean, they do create large atmospheric like showers of charged particles, including ions and electrons. But this mostly is concerning like the high altitude, like ionosphere, stratosphere stuff. But apparently, like, who knows? Maybe some of these particles do reach Earth, actually. Like, I don't really know. I mean, their energy is lower than the regular cosmic rays. So, I mean, the cosmic rays, which are the galactic cosmic rays, I mean, the galactic cosmic rays their typical energies could be a giga electron volt. Whereas these protons from the sun, they're typically in like 10 or 100 mega electron volts. So that would be a 10 or 100 times smaller energy than the galactic cosmic rays. But still, who knows? Because of their higher flux, maybe they might cause some other effects. By the way, in high altitude, like when we're talking about like airplanes, especially like the planes that fly near the polar areas, they also receive a higher radiation dose during these events, and other things like that happen. But on the level of like sea level, at the bottom of the atmosphere, like not much changes, to be honest. So it's mostly like polar regions and high altitudes that are affected. Okay, and what was else? What was the other part? So what are GOES measuring? So it's this graph, I assume, that we're talking about. So GOES is a geostationary, I'm not sure what O means, like Earth observing satellite, let's just call it this. So geostationary means it's at an altitude of about 36,000 kilometers, so it's pretty far away from Earth. So it's kind of outside the Earth's magnetosphere, so it receives, well, more or less, there's obviously some elevated magnetic field there still, but with respect to the solar wind, I mean, but still mostly outside the Earth's magnetosphere. So, and they measure literally the flux of these protons. You see, the particles per centimeter squared per second per steradian. So, steradian is a solid angle. So, 4 pi steradians, which is roughly 12 and a half, would be like the whole sky. So, if you 1/12 of the sky would be one steradian roughly. So yeah, in the typical flux, right now it's slightly elevated from this last storm, but still, as you can see, the typical flux around 10 mega electron volt range is about one particle per centimeter per second, centimeter squared, I mean. And as you can see, their threshold for the storm is 10 particles, right? So 10 times higher than usual. And yeah, that's what we're measuring. So yeah, as you can see, it's not a whole lot of particles. I mean, one particle per centimeter per second. I mean, in a centimeter of water, like a cubic centimeter of water, there's what, like 10 to the 23rd power of particles. But still, since these protons have a lot of energy, you see 10 mega electron volts, and again, like the ionization energy of a hydrogen atom, let's say, is 13 electron volts, right? So one such proton, like theoretically, might ionize how many? I don't know, like 100,000 atoms, something like that. And that's a lot. That's a big charge already, right? If we're talking about 1 centimeter cube. But obviously, as I've said, this is the flux at the geostationary orbit, so it would be much lower when they come to Earth, because the magnetosphere would still like deviate them significantly. And once again, as I've said, in lower latitudes, the flux would be minuscule. Like most of this stuff gets into the polar regions, after all. But yeah, still, I mean, maybe it can cause something else. Yeah, like as usual, we're only starting to study all of this stuff. Like humanity has only learned about this very recently, like what, 50 years or something. Uh, so yeah, much more research would be needed of how this might impact, uh, well, whatever really, like whatever processes that happen on the Earth and in our nearest space environment. Well, hopefully this answers the question.